Whether screen is visible at your all screen is visible. Shantanu, please reply me.
Yes, sir, visible.
Saurabh Shinde. Yeah, okay, okay, thank you. Uh, so good afternoon, all of you. This is the second lecture of our non-conventional machining subject. Okay, in the morning we have started our chapter lecture number one, and in that lecture we have seen the syllabus, introduction to subject feature. Okay, what are the general points? So that point we have seen in the morning lecture, today's morning lecture. Also, we have seen the unit-wise syllabus also. Okay, and now at the starting of the unit number one, I would like to start with the one basic question. That is, why do we need non-conventional machining process, or why we do need advanced machining process? Okay, simple. That is, why to study this subject? Okay, so answer of that question we are going to see in this lecture. Okay, answer of that question we are going to see in this lecture. Okay, so let us start with the your on the your screen. You are seeing the first slide. Now, I would like to tell from the introduction of that basic part. Okay, as we have discussed in the first lecture, that is the prerequisite of this our subject is a is manufacturing processes. Okay, so as we you can see on the slide, our manufacturing processes can be broadly divided into the two manufacturing processes. Okay, our manufacturing processes can be broadly divided into the two processes. One is a primary manufacturing process. Okay, and the second is the secondary manufacturing process. Okay, one is the primary manufacturing processes, and the second is the secondary manufacturing. Now the question arises that what is mean by the primary manufacturing process? Okay, so this primary manufacturing processes this provide basic shape and the size to the your material. Material means what? Your work is material. Primary manufacturing processes provide basic shape and size to the your work material as per the now whatever the basic size and shape is there now. So that will be the as per the your designer's requirement. Okay. Now the again question arises is that what are that primary manufacturing? What are the what are the that primary manufacturing process? So here I have written some examples. So casting process, as you know, in the MP process, MP subject you have studied that casting. So that is the primary manufacturing process. Then forming process, then powder metallurgy. Now this powder metallurgy, about this you are going to learn in the metallurgy subject. Okay, separate chapter is there, or separate unit is there in that metallurgy subject. So casting, forming, okay, powder metal. So these are the primary manufacturing process because they are, that processes are providing basic shape and size to the material. Basic, okay, not with the high finish or with the accurate dimension. These are just the basic shape and size they will provide. So it is called primary manufacturing. And the second group of our manufacturing process is the secondary manufacturing process. Okay, so this provides okay. So secondary manufacturing process. So these secondary manufacturing processes provide the final shape and size with tighter control on the dimension. That means that finishing will be the final finishing, surface finishing. I'm talking about surface finishing, and what are the shape is there, that will be the final, and it's a dimension. That means it's the size will be with the tighter control on the dimension. That means whatever the dimensions are given on the your drawing, okay, which is given by the designer. So as per that same dimension, okay, as per the size, with all control on the your dimension, you will get your that your product. So the processes which gives the or which provide the final shape and size with tighter control on your dimension, and also what are the surface finish is there, okay, surface finish is there, so that will be accurate. So that processes are called the secondary manufacturing process. Getting it? Now, in that again secondary manufacturing processes, another subgroup is there, that is the material removal process. That is the material removal process. Okay, whatever the material removal processes are there, so that processes are mainly belongs to this secondary manufacturing process. Now, what is mean by material removal processes? That we will see. So the processes which are used to remove the material from the your work is, that is called the material removal processes, and that are belong to the secondary manufacturing processes, because that processes provide us final shape, type with the as per the with we can call accurate dimension and the surface finish. Okay, accurate dimension and surface finishing. Now again, whatever the material removal processes are there, no, so that are divided into mainly two groups. Whatever material removal processes are there, no, that are divided into two processes. Okay, now which are that two processes? One is the your conventional machining process. One is your conventional machining process. Okay, conventional machining process is the one of process belongs to the material removal. Okay, now what is mean by conventional manufacturing process? Because since the morning I was talking about the conventional and non-conventional, correct? So what are the conventional? So the processes, okay, which are mostly remove the material in the form of sheet. Okay, the processes mostly remove metal in the form of sheet by applying forces on the your workpiece or work material with a, how they are going to apply the force on the your workpiece with a edge-shaped cutting tool. Okay, the processes which are mainly used or mostly used to remove the material in the form of chips by applying force on the workpiece with the edge-shaped cutting tool. Okay, which is or that is harder than the your workpiece. Okay, whatever the your tool material is there, no, or the cutting tool, so its material is always harder than the harder for hardness. Okay, harder than the your work equipment. So that cutting tool, with the help of that cutting tool, we are applying force, okay, on home, on your workpiece, okay, on your workpiece, so that material will be removed from your workpiece in the form of chip. So that process is called conventional machining process. That process is called conventional machining process. Now, again, a small question arises is that what are that processes? What are that processes? So, for that purpose, I have given here example. I have one example. You can see examples like turning operation of process, boring operation, then milling, shaping, plotting, grinding. So whatever the processes I have mentioned here, that all these are belongs to the conventional machining processes. Now, I think you got the point that what are the operations we are doing at our workshop, that means lathe machining or milling machining or the grinder. Okay, their physical contact occurs. That means we are using tool and we are giving force to the tool, that cutting tool, okay, so that it will uh, touch to your work is physical touching will be there. Okay, physical contact will occur between your tool and your workpiece, and due to the application of the force, the material will be removed from your workpiece. Okay, and you will get the final shape with the tighter control on your side. So that process is called the conventional machining process. So conventional machining processes are the material removal processes. But here we have to apply the force on your workpiece with the help of edge cutting tool. Okay, and the material of the tool is always harder than your workpiece material. That is the basic requirement for the conventional machining process. Please remember this. Okay, getting it. And what are the application? Sorry, what are the examples of the conventional machining processes? Whatever the processes we have learned in the MT or MT subject, so all are the processes belong to this conventional machine process. Okay, so in that you can take example of turning, borings, or whatever the drilling also. Okay, okay. Because what drilling machine also the conventional machine process. Okay, so that is the process or the equation. Okay, getting it. Now another second group of the uh, material removal processes is the non-traditional or non-conventional machining or manufacturing processes. Okay. Another group of material removal processes is the non-traditional or non-conventional machining or manufacturing process. Now, what is meant by this non-conventional machining process or what is meant by non-traditional machining processes? That we will see here. So I will take the definition. It is defined as a group of processes. Once again, I will repeat. It is defined as a group of processes that remove excess material by, okay, it is a group of processes. It is not an individual process. It is not a one process. It is a group of processes that remove excess material, okay, that remove excess material by various techniques. How they are going to remove material? The answer is that by various techniques involving mechanical, thermal, electrical, or chemical energy, or okay, by involving mechanical, electrical, or chemical, or thermal energy, or combination of these energies. Okay, where they are going to use these energies, okay, to remove the excess material from your workpiece. But the condition is that, but do not use a sharp cutting tool. But do not use a sharp cutting tool as it is needed or as it needs to be used for a traditional machine process. Okay, as like traditional machine processes, because we know that cutting tool it is used in the traditional machining or conventional machine process. But here in non-conventional, not traditional machining, we are not going to use sharp cutting tool. We are not going to use or we are not using sharp cutting tool. Here, how the material removal will happen? It will happen due to the various techniques, okay, which involve the mechanical or electrical or thermal or chemical energy or combination of this energy. Okay, so due to that only material removal will occur. So that process is called non-conventional or non-traditional machining. Okay, so our subject is totally depend on this process. Okay, no physical contact between your tool and work is the basic fundament of the non-conventional. I once again I will repeat: no physical contact between tool and your working. The second, no use of sharp cutting tool. No use of sharp cutting tool. Okay. The basic requirement is that it involves mechanical energy, electrical energy, or the combination of any energy. So due to that material removal occurs. So that process is called non-conventional, non-traditional machining process. Now again, the small question arises is that what are that process? What are that process? So abrasive jet machining, that is AJF, then electric discharge machining or electro discharge machining, EDF, electrochemical machining, processes we are going to learn in chapter number 2 to 5. So all the processes are belongs to the non-conventional machine processes or non-traditional machine processes. Okay, getting it? Okay, understood or not? Yeah. Do you got the answer of the what is mean by conventional process and what does mean by non-conventional or non-traditional machine processes? Okay, say yes or no in the chat box. Say yes or no whether you got answer of or not. What is mean by conventional machine process and what is mean by non-traditional or non-conventional? Okay, now let us move for the next step. Now here the now we have just understood the meaning of non-conventional or non-traditional machine. But the first and foremost question arises uh, in everybody's mind is that why do we need advanced or non-conventional machine processes? Why do we need advanced or non-conventional machine? Okay, because when there are already so many types of traditional and conventional machine processes available. Okay, and about that all processes which we all already know. Okay, because manufacturing processes in that we have studied. Okay, so the small question is that why do we need this advanced machine process, or why we do need to study this non-conventional machine? So this is the first and foremost question arises in everybody's mind. Why do we need advanced or non-conventional machine process? Okay, getting it. Now, once again, I am repeating that which are the conventional machine processes you should know. So, for example, whatever your turning, milling, grinding, shaping, and so on, all these are the processes are there now that are belongs to the your conventional or your traditional machine processes. Okay, so we all know that these there's okay. Now we'll start with the answer of the our question that why do we need. So we all know that. So now there's also a lot of research is going on in the field of engineering material. Okay, because if you search on the Google, no, related to the material science or metal. Okay, so in a large amount of a large number of research paper you will get about that research in the field of engineering material. Okay, so already we know that a lot of research is going on in the field of engineering materials. Okay, now if you want to classify the our engineering material, no? Okay, I think this point you may know because you are studying, you are learning that material subject. So yeah, if you want to classify your engineering materials, no? Materials, then you can classify these uh, materials into the three categories. Okay, into the three categories. Okay, say engineering materials you can classify into the three categories. Okay, so engineering materials you can classify it into the three groups. One is the metal and alloy, metal and alloy. Then second group is the plastics and composite. Whatever the engineering materials are there, no. So that engineering materials you can classify it into three groups. One is the metals and alloy. Then second is the plastics and composite. Okay, and third one is the your ceramic material. Okay. Now these days or what are the today's days are there now. So actually, the metals, especially the your plastic, then composite, and this ceramic are most popular among the industry. You know that what are the materials of materials like plastic, ceramic, or composites are there. So all these are most or more popular amongst the industries. Okay, or industry user. Okay, then you are the metal. Then you are the metal and all that because you know that the composite. Okay, it may be the natural composite or fiber. So in that field, more research are going on today in the today's era. So your plastic, composite, and the ceramic material is the more popular. Okay, as compared to your as compared to our in the metal in the industry I'm talking now. So definitely these new materials, plastic, composite, ceramic. So these new materials have the advantage over the other materials. Okay, these materials uh, have the more advantage as compared to or as over to the other metals. Okay, which are the commonly used or especially metal and alloys. Okay, especially metal and the alloys. Okay, having the good different I can call more advantage as compared to the metal and your alloys. So another question arises is that okay, question is that how to machine these new metals. Okay, how to machine means now see please note down the one small concept that in our non-custom machining process, whatever the machine means what here we have to consider as a or we have to take its meaning as a machine means one operation. Whatever cutting, turning, we are saying no. So like that, machining of metal means what I am talking about the operation machine. Okay, so the question is Rajesh is that question is that how to machine these new materials because if we see the ceramic normally we use ceramic tools for cutting the metals. Okay, we know that simple. Ceramic tools are used for cutting the metals and the alloys or other metals. Okay, now when your workpiece itself it is made up of your hard metal like your ceramic, then the question arises is that which material will you use to cut or to cut or to machine your cutting ceramic because in conventional machining your tool should be harder than the your workpiece metal. Correct. In conventional machining, your tool metal should be harder than the your workpiece metal. But now here situation is that your ceramic itself is a workpiece metal. Your ceramic, as we know that ceramic having the high hardness. So ceramic is a harder material, and ceramic is your workpiece material. The question arises is that which material will you use for cutting ceramic? Okay, and we know that tool should be if you consider the conventional machining, then we know that the tool should be much harder than your workpiece material. If workpiece itself is harder than your tool material, then how to machine it? This was this question arises, and this was the one of the reasons that the researchers in the field of this manufacturing or in the field of machining started thinking. Okay, this was the one of the reason. Okay, one of the reason that researchers in the field of machining or in the field of manufacturing that researchers started thinking to evolve new type of machining process. To evolve means what? To develop, to invent new type of machining processes where work is harder, hardness is not barrel for this machine. Okay, they are trying to that researchers started thinking about the solution. A solution should be like that. There should the process they have to develop or they have to uh, evolve the process where your work is hardness should not be the barrier or should not be the any limitation about the work is hardness for the cutting or for the machining. And after research or after studying, researchers got the solution and they found the solution and it is that solution it is known as the advanced machining process. Advanced machining. Okay, why we now I will tell why we do why we do need this advanced machine process. Okay, because with the help of this advanced machine process, we can machine is what I'm talking about the operation. We can machine any hard material, any type of workpiece material, or any type of work material. We can machine it, or we can cut it. There is no barrier about the any hardness. Okay, for that purpose, we should know the advanced machine process. So this is the reason of the why to study this subject or why do we need. Okay, but now I think you are getting the point that how the evaluation of this advanced machine process, how this need of advanced machine process arises, how this invented advanced machine. Okay, getting or not? Just to say yes or no in the chat box. Okay, there should please be interactive because we are in the virtual mode. Okay, you are at your end. I'm at in this cabin. Okay, and I am teaching to you. Okay, but I am trying to give my 101. Are you trying to grab that all the whatever the I'm explaining? Whether you are getting or not, for that purpose, I am asking this question, and you have to give the answer in just a yes or no. If you are saying yes, I can go further. If you are saying no, I can explain once again. This is a just a basic lecture for our non-conventional process. Yet I have not started it from the subject. Okay. Here trying to explain you that how this advanced machining or how non-conventional machining subject is important for everyone. And the reason is this. This slide is the first reason. Okay, I have started with the how our engineering material is classified into the three groups. Okay, out of that, today's new materials are popular in the industry than they were in the more advantages, okay, or other materials. Okay, so and if ceramic material is used as work, then another question arises is that how to machine that or how to cut that ceramic because ceramic is harder. And we know that the tool should be the harder, much harder than the work piece material. But so the uh, researchers starting thinking and they have evolved they have started thinking and they think to evolve the new types of processes where there should not be the work piece hardness is a not is a, that is that should not be the barrier for the work material. And they got the solution that is the advanced machine process. Advanced machine process. Okay, so this is the first reason that why do we need to study this advanced machine. Okay, now let us see the next that is as we know that another question arises is that what are the present day demands? What are the present day demands trends in the industry? Okay, what are the present day demand trends in various kinds of industry? Okay, now industries in that especially, or we'll take the high tech industry. Okay, just like aerospace industry, missile industry. So, what are their demand in the industry? Aerospace industry, missile industry, automobile industry, or nuclear reactor, etc. So the engineering materials which are in demand in the present day now, so they should have much superior property. What are the materials required in the like industry, or I have mentioned high tech industry. No? So in that industry, what are the material engineering materials required? No? So that material should have much superior property than the commonly used material, commonly used metals and all. So these engineering materials should have ultra high strength, okay, very high hardness, very high temperature resistance because because such properties are essential requirement of certain components, okay, in that industry. Now, which are that component having this such type of high properties? So the we can I will give the one example. Okay, because I'm telling that here there are such a component that for the component they need such type of engineering metal having the superior property. So here I will take the example of I will tell the automobile. Okay, the turbine. So a turbine blade. Okay, so turbine blade is because they operate. If you know, is that turbine blade all this. So in that turbine blade, other turbine, cup line and filter turbine. Okay, upfront. So they operate gas turbine also in nuclear power plant. If you want to consider. So that turbine blades are operated at 1100 or 1200 degrees centigrade. So at that high temperature, these components should be able to retain their silence. Okay, at that high temperature, these components should be able to retain their shape, size, and other properties, okay, while they are in use. Okay, because when ultra high strong material are used as workpiece material, then the question arises is that how to machine such components. Okay, what are the industries I have mentioned that aerospace, missile, automobile, nuclear reactor. So in that industries in present days, there is a trend that they need engineering material having the much superior property. Okay, but if or when we are using this high ultra high strength materials no, okay, as a workpiece metal, then another question arises is that, or we can call it as a limitation of our conventional is that how to machine such metal, how to machine is not how to cut or how to turn on do the operation on such metal. So because it becomes very difficult to uh, machine them by conventional machining process, because we know that in conventional machining processes, our tool should be the harder than the work with. That is the basic condition. Okay, but here we are using the ultra high strong material for aerospace industry or missile or
There's a demand to use.
having the much superior property. And in that superior property, I'm taking the example of ultra high strength material. Okay, but if you use that ultra high strength material, okay, for these applications, then another question arises is that how to machine such material, and it becomes very difficult to cut or to machine them by the conventional machining method, because the basic principle or basic fundamental of these processes of conventional machining processes is that your tool metal should be harder than the your work is metal hardness. Okay, so as a result of this, researchers started thinking about the to find out the solution of this processes, or to find out the solution for the cutting off or machining of this such a high ultra strong metal. Okay, so as a result of this, researchers over a period of time evolved a new machining processes. Okay, they are starting to solve that problem, and at the end, they got the solution. And the name of the solution is that your advanced machining process. Advanced machining process. This is the second reason of why do we need advanced machining. Okay, or I will say that this is the answer number two about the question why to study this advanced machining. Okay, if you study this advanced machining or if you study this non-conventional machining process, non-conventional machining subject, then you will be able to get or you will be able to understand the knowledge about the different engineering superior material, I will say. Okay, which are used in the different automobile or aerospace missile industry, and to cut or to machine such materials, you should know the different process, and that process is you are going to learn in this subject. Okay, so this is the second reason about the why we do need the advanced machining process. Why we do need the advanced machining? Because while using this advanced machining or while using this non-commercial machining process now, there is a no barrier, there is a no limitation about hardness. Okay, while using advanced machining processes, hardness does not remain as a barrier for your machining of any type. Okay, there is a no restriction over your hardness. Okay, your material may be having the high hardness or harder material, no problem. You can cut any material having any hardness. Okay, you can cut using this advanced machine. That we are going to learn in the uh, chapter number 2, 3, 4, 5. Okay, this is the second point about the why do we need advanced machine. Now another, okay, same question I'm taking. Why do we need advanced machine? Okay, so and we know that there are various limitations with your our conventional machine processes. There are various limitations with the conventional machine processes or machining method. Like for example, workpiece hardness, it should be lower than your tool hardness. That is a basic fundamental, basic requirement of conventional. But the present day industry, in many cases, in many cases, the present day industries in many cases also they need very high level of surface finish. They need very high level of surface finish. That means your surface roughness value. That means your surface roughness value in nanometer. Whatever the surface finish is there, that is surface roughness value, RA value it is called. So that is it is measured in the nanometer. So they want should be very low. Yeah. Surface roughness value should be very low. Means what? Your surface finish should be very high level. Okay, so some industries are they are in the demand of nano level surface finish. Okay, nano level surface finish they want. Okay, nano level surface finish means that is your roughness value, surface roughness RA value should be in the range of 1 nanometer. Okay, 1 nanometer to 991 nanometer. See, okay, 1 nanometer to 991, sorry, 999 nanometer. Up to that range of surface reference value, some industries are demanding your product. Okay, again, what are the product? I will he'll give one example. So there are various components, just like your turbine blade, okay, which are 3D in nature, because we know that turbine blade having the euro, if you cut the turbine blade, then you will get the shape of the Eurofight. So these are the turbine blade, which is are 3D in nature, and they are used in a machine or any system. Turbine blades are used in a machine or a system. So the question arises is that how to make such a 3D component? Okay, because see, we want high surface finish. We want surface surface value should be sorry, surface surface uh, value should be very low. Okay, super surface finish. We want accurate shape and size. So question arises is that how to make such a 3D component, because your turbine blade, if you take now, it is having the 3D in nature. So how to make such a 3D component? So it is very difficult to make these 3D components by conventional machining methods, because many of these 3D components now are complex in nature. Okay, if you take an example of our heart, okay, or brain also, I will take the heart. Okay, if you in the medicine, sorry, medical industry, okay, if you have seen in doctor labs, no, sometimes we are observing that they having the model of heart, huh? Correct, or any bone, okay, joint. How they are going to manufacture such joints or the parts as a demo? So such a 3D component, it is very difficult to make this 3D component by our conventional machine process. Whether it is possible using to make that 3D component using our conventional lathe, drilling, or your shaper machine or milling machine, it is very difficult to make, because that 3D components are complex in nature. They are again these 3D components are made of super alloys material, which are very hard. Super alloys material, very hard, very hard metal. So some of these super alloys, okay, have the hardness as good as or even more than the our cutting tool hardness, cutting tool metal. Okay, super alloy metal or hardness that of the your cutting tool metal. So hence, due to the complex geometry of your 3D hardness, it is very difficult to machine them by using your conversion machining process or conversion machining tool. It is very difficult to produce or to manufacture such complicated components with a very high with a accurate size and shape. Okay, it is difficult to machine them on conventional machine tool side by the conventional method. Hence, many industries. Okay, so due to this limitation or due to this problem, many industries use CNC machine tools. Yeah, if you are watching some videos on the YouTube, then you come to know that in automobile industry or many industries they are using CNC machine. Yeah, they are uh, operating all the operations using CNC. So many industries are use the CNC machine tool. Okay, to overcome why to use the CNC machine? To overcome the problem of complexity of your geometry of your 3D component. So now CNC machine is that are computer numerical control machine tool. CNC, computer numerical control machine. Okay, you have this CAD CAM CA subject. So in that you are going to learn CNC. Okay, or many times in short it is called CNC machine tool. Okay, to get the complex geometry of your 3D component with accurate size and shape. In main industry, they're trying to prefer the CNC machine tool. Okay. Again, further, if increase the workpiece hardness is will be there, no. So that increase the workpiece hardness that will lead to the decrease economic that cutting speed. Whatever the economic cutting speed is there, no? Average cutting speed is there. So that will be reduced there. If you want to, if your workpiece is hardness having the more hardness, that time your economic cutting speed will be there, no? That will decrease. Okay, so that means if the economy of your cutting tool will decrease, that means your productivity goes down. Okay, by this I'm talking about your conventional machine, or you get lower productivity. Okay, that means if production rate will be less, or if your productivity will be less, that means more expensive. That component value will be, or price will be more. That means more expensive component will be there. And again, your that machining process will be the time consuming. Getting it? So again, non-metals are used more. Sometimes non-metals are also used as a workpiece material. Okay, non-metals I'm talking. Non-metals are also used as a workpiece material, just like non-metals are stainless steel. Uh, again, your high strength temperature resistance to alloys. So again, another question arises is that how we can machine them, okay, non-metallic component. Okay, non-metallic component. How to machine them? That question arises is so further when the as we know that further when tool metal hardness is very close to your workpiece metal hardness, then you require much superior quality of your cutting tool. Correct? If your hardness of your workpiece and tool is very close to each other, then you require much superior quality of your cutting tool. And such feasibility of such a it is mm, not feasible. Okay, it is always not feasible. Okay, because if, for example, cutting tool having the 500 HRC hardness and work is having the 480, so it is very difficult to find such a cutting tool having the near about that cutting hardness. So that is always not feasible. So the solution for such a problem is that you have to go for advanced machine tools. Okay, to cut the non-material non metals. Okay, like a stainless steel or high strength temperature resistance to alloys. Okay, that is line metal. Okay, that means again tool metal which is near about the so such type of metals if you want to cut, then you have the only one solution, that is you need to go for the advanced machining process. Okay, so this is the fourth one reason that why do we need a advanced machining process. Okay, now apart from this workpiece metal property, okay, there are again, okay, I was talking about only uh, metallurgy part, huh? That means metal property. Okay, so from apart from the workpiece metal property, there are another aspect, that is there are product requirement also there, okay, which are very complex in shape. Okay, sometimes your product requirement is that product having the complex shape. Sometimes you may require to machine a component in a inaccessible area. Inaccessible means what in Marathi we can call uh, or I'm translating it in the English. Okay. Inaccessible area, okay, where your tool is not going to cut or to remove the metal using the conventional machine. So you may be required to machine a component in an inaccessible area, which may or which may not be feasible for your conventional machine tool or machine tool. So, say for example, say a single point cutting tool you are using or multi-point cutting tool, and there you definitely such using single point cutting tool, it is not feasible to cut inaccessible areas of your complex shape component. So that time definitely you require advanced machine process, or you will definitely require the non-conventional machine processes to get the accurate size and shape of your such component. Okay, again, sometimes what are the tolerance is there, no? Okay, dimension tolerance requirement maybe very very small, say up to 10 micrometer or even smaller than 10 micrometer, depending upon the requirement of component. If you want to attain that much tolerance, then it is difficult to attain achieve by the convention. You have to go for other system. Okay. Another product requirement is that you need better surface integrity. You need better surface integrity. Okay, it is very important to understand that the what surface integrity means. Okay, surface integrity I am talking about. Surface integrity means what? The surface after machining should not have any defect. Okay, the surface after machining should not have any defect such as micro cracks, poor surface finish, or heat affected zone. Okay, so we have to achieve the better surface integrity, and that you can actually use the advanced machine process or non. Okay, such defects or poor surface integrity should not be there. Otherwise, whatever the your component maybe is whatever product or company is there, no, that may get rejected during the game. Okay, so to achieve the better surface integrity, you have to go for the your advanced machine. Again, the next reason or product requirement. Okay, so that again you will get the answer of why do we need advanced machine. That miniaturization of the product. Okay, miniaturization of products is another aspect which forces to use advanced machine tools. Miniaturization is what micro pump is there. Okay, micro mixture is there. Okay, small micron our products are getting. Okay, so the miniaturization of product is another aspect which forces to use advanced machine tools. You can see in the older days or even today also we use the landline in the older days we try to use landline phones, okay, which are much bigger in size, okay, as compared to today's mobile phones. Okay, so these mobile phones have much more now. So if you see the mobile phones, so these mobile phones have much more capabilities than your landline phones. Correct. So you can again you can internet with the help of the these today's smartphones. Okay, you can send the emails and with the financial transactions also with the help of the mobile phones. Okay, everything is compacted into small size of product. That is your mobile. It is called the miniaturization of the product from landline to the our smartphone. It is called the miniaturization. Okay, so that is the another aspect of use the advanced machine process. So this miniature again see in older days computer say in 70s 80s era, what are the our room is there, so that much area is in your computer that was. Okay, so room size could not have the memory more than what you have in the laptop. Okay, in that now in five, sorry, 1 TB or 2 TB, like that we have the capacity of in the laptop. Okay, earlier it was two 216 something that GB or MB, okay, which is very small in size now to this. Okay, so this miniaturization requires very small size of component with different capability. So for machining such a component or to produce such component, you definitely require processes other than our conventional machining process. Now, which are the processes other than conventional? These are our advanced machining processes. Correct. So this is another aspect of another result of that why do we need the advanced machining. Okay, getting it. Yes. Say yes or no in the chat box. Whether are you getting or not. Now I'm having the another one more reason of this why do we need our system. uh, what I will do, I will continue that point in the next section because I have to do some practical examples also. Okay, we'll continue this point, okay, because I still one, okay. So example I will take. Now I request all of you, I think whatever I taught today, okay, so through that or through this today's lecture, uh, you might be you got the reason of that. What do we need, or what is the importance of the subject? Okay. Now, I request all of you, please write down your roll number in the chat box, and after writing your roll number in chat box, you can okay. Please write down your roll number in chat box. You have Shivraj. Please, all of you, I request once again, all of you, please write down your roll number in chat box and you can leave.